that is where you can see the damage here on the end of the veins. And you see, in that area, the vein is quite tight, because here we don't want to have a leak. In that area, it's loose. And that is the noise what you hear when the system is running. It sounds a little bit like a diesel engine. And this is the noise when the vein is pushed, when the vein passes that one here. So it's pushed back on the other side. And now it's nearly no gap left. So that is the system here inside. That unit is built 2005. In that time, it is here in that area, it's pure aluminium. Today it's covered with aluminium oxide with ceramic here inside to make it more resistance against corrosion and or foreign particles or whatever. Do you have a screwdriver for me?
Yeah.
Now, what is the difference in the materials on the typical unit and the seawater unit? I mean, I know the housing is...
That is bronze.
Right.
That is aluminium bronze. That is the same material. It's a copper, aluminium, nickel, iron alloy, and that is the same material used for ship propellers.
Right.
Yeah. So, and the O-rings is the same. That is POM, polyoxymethylene. This is very tough.
So that is a different material as well?
No.
Oh,
The plastic stays plastic, but everything what is aluminium goes to bronze or to aluminium bronze.
What about on the pump side?
Yeah. The coupling stays aluminium, but it's going to be anodized to protect the surface. You know, all the fittings, pipes, everything is 316 Ti.
So all that stays stainless?
But what is brass changed over to stainless steel. All that is stainless. Our own pumps, the pump head is also made from aluminium bronze. If we are purchasing pumps for the smaller ones, then we nickel plate everything.
Okay.
So everything what can be in contact with salt water is nickel plated. That is a very tough surface.
Right.
So that is what we are doing. So and here we are using. That is the rotating part of the mechanical seal. We have graphite over here, which is the soft, and we have silicium carbide. That is also ceramic here inside. What you see here. The bearings are lifetime greased, also stainless steel, and that is, for example, also polyoxymethylene. We added that 12 years ago. It was not right in the beginning, but the advantage is the rotator, you see, the cylinder is a little bit larger than the rest, so that part runs into here. Even if we have a lot of sand or welding slack or whatever, and it happened once, 12, 13 years ago, that something moved in between that gap, and then the thing was blocked. And we said, okay, we will add that plastic here. If we have trouble with foreign parts, they will be pushed into the plastic, but you never get the risk of a cold welding, you know? That's the reason for that part over here. That is the system. That pump is a 3-cylinder pump. That system is able to give 3% if all the pistons are pushing the foam concentrate into the line, or if we open that valve, then for the pistons, they are moving here, then it's easier to push the foam concentrate back on the suction side instead of building up pressure and pushing the foam concentrate into the water line. So that is what we call cylinder disconnection. And so therefore we have, if we would have a FM high X foam system, we would connect only one cylinder for reduce the foam concentrate or the admixture rate from 3% down to 2%. Here it's from 3% down to 1%.
If we were doing like the foam trailer, that's
you see this is one of the check valves. Pressure side and suction side are the same check valves, hard sealed. The spring is quite light. It's only necessary if we have alcohol resistant foam, and which is very viscous. The spring should be strong enough to push the valve cone back on its seat. But we have never have a gluing or whatever because we are using hard sealed. If you look into the hole here on the top, I will disassemble it completely so that you have to do some work.
Alrighty.
So here you can see one piston inside, and these are made from ceramic, so you never see any. That is a very tough and it's absolute resistant against everything. So ceramic, and you will see how the piston are moving backwards and forwards. Now the left one, the one on the right, and so that will give the three. Remember the sinus relation, the three pistons, 120 degrees on the crankshaft will give us a constant flow coming out of the system into the water flow. So up to the 4-inch unit, because we are using this housing also for fire brigade purposes, we supply the unit with these threaded flanges, so we can go for ANSI or DIN or whatever you like. For the larger houses like the FT4000, you see it over here, that is the flanges are casted. So therefore we have to know right from the beginning if it's going to be an ANSI or a DIN flange or whatever. What I always prefer is raised face flanges, because there the sealing sits, in my opinion, it sits better. But it's no problem. I learned that also flat face flange can be connected to a raised face one. So that's not a big issue. So here you can also see the damper in the clutch. It's always the same. We have the oil gauge. We have a I'm too weak. We have a spanner for opening that. And as I told you yesterday, these, I'm an honest guy. If that is moving here in between, and the veins are trying to pass that will block the system. And then the water flow is blocked. Not completely, but it will throttle down the water flow. So if you look inside and you see a stone or sand, that will not harm the unit. But these long, tiny parts, these are critical. And what happens sometimes, that is a ventilated dipstick, and because of the risk that the unit inside the packing falls apart or whatever, to avoid that the oil is flowing out, we are delivering all the unit with a transport plug. And if you forget to take the transport plug out and the system runs, every time you can touch it, but you can feel that it's getting warm. And we have air here on top, and that air will expand, and then we will get a high pressure inside the crankcase where it shouldn't be. So therefore, and then the radial shaft seals, for example, the lip can slip over, and then you will get an oil leak. So therefore it's important before you bring the system in operation to take the plug away, throw it away, and put the ventilated dipstick in.
And that's the only transport plug there is?
Yeah, there is, like you see here at the motor. That is how we transport it, that we covered the flanges. We try to use yellow ones that everyone can see them. For the smaller ones, we are using these transparent polyethylene because yellow is not available. And it happens that they moved inside because they were forgotten during the initial commissioning or the installation. All that happened.
Now, on the newer ones where you're making your own pump,
Yeah.
don't you have a dipstick that is vented that can also remain
No,
as a transport?
we have, in the beginning, a year ago, we delivered with a dipstick, but we delivered something to Singapore, a big system, and they put the box on the side, and the oil was flowing out. And you can't imagine what kind of trouble that is. And so for that reason, even our own, the big
So now
pumps,
you went back to having a transport plug on?
yeah, definitely. And we will always put the dipstick in a transparent small bag here on the air bleeding to be sure that that won't happen again. Then customs and our customer down there in Singapore get in trouble because the oil was flowing out.
I wasn't aware that you switched back to
We
this for a
switched
while.
back for,
Yeah.
even for our
Okay.
for nearly a year now.
Okay.
So we have flushing lines, drainer, three-way ball valve, all the same like we have seen it on the small unit. So I think that makes it a little bit more clear. You see, nothing is spring-loaded or whatever. These are these U-shaped vanes inside which can move inside. So it's a very simple system. Yeah, we have not much movable parts or whatever inside. That is espionage.
No? Das Training.